Hello, students, and welcome to your June 15th lesson. We will start by responding in our Do Now to a prompt about Smile Power. It's Smile Power Day. Our objective will be to learn about proportional and non-proportional relationships, and our assignment will be to complete the 2 pages. And before you exit the meeting, make sure you've shown me both of your pages completed. Whether you're in school or at home, you need to do that. If you finish early, I do have some activities for you below. So our do now for today, for Smile Power Day, goes like this. A smile is powerful. An unexpected smile can change a mind and foster a positive attitude. Why does looking at people smiling, even just pictures of people smiling, uplift us and make us feel better? So I would love you to answer that right there. And maybe do so with a smile. So let's get started with our lesson. Our topic today is proportional versus non-proportional relationships. So if the ratios are rates, now we talked about rates and we talked about unit rates, but if you have two separate quantities, if the ratios or rates of those two quantities are equal, then the quantities are also proportional. If the ratios or rates of the two quantities are not equal, then the quantities are non-proportional, non or not proportional. So, excuse me, let's take a look at some examples. We've got Eric and Lucy ran 20 minutes on each on the treadmill at the gym. The table below shows the number of calories each has burned after 5-minute intervals. Complete each table and determine the type of relationship. So we're going to divide 70 by 5. We're going to divide 140 by 10. We're going to divide 210 by 15, and we're going to divide 280 by 20. And in this case, when we divide 70 by 5, we've got 14 calories per minute. For the next set, 10 divided by 140, also 14 calories per minute. And the same with 210 divided by 15 also comes out to 14 calories per minute. And 280 divided by 20 is also 14 calories per minute. So this is a proportional relationship. So we can say the calories burned by Eric are proportional to the time. We should say are proportional to the time because every ratio in the table is equal. And we see that right here. So let's take a look at Lucy. 45 divided by 5 would be 9 calories per minute. She's not burning as much as Eric did. She might be a smaller person who burned fewer calories. 90 divided by 10 is 10 calories per minute. Well, we already know right there that this is not a proportional relationship. 120 divided by 15, 8 calories per, 90 divided by 10. I wrote 10, I meant to write 9. Sorry about that. 120 divided by 15, this is our 8 calories per minute. And 180 divided by 20, now we're back up to 9 calories per minute. So what we have here is an outlier in at 15 with 120 calories burned. We have an outlier where there are 8 calories burned per minute. So in the case of Lucy, we will say that the calories burned by Lucy are non-proportional to the time because the ratio of 120 to 15 is not equal to the others. We can write it like this. We've learned that 120 to 15. It's kind of like, if you have a pizza eating contest, if you can eat one pizza in 15 minutes, well, in 30 minutes, you would expect, if it were proportional, that you could eat 2 pizzas and you'd be pretty full afterwards. All right, so let's do some extra practice. Maybe I'll do a few of them, and I'd like to see you try some on your own. We're going to determine whether the quantities in each table represent a proportional relationship. If they do, if the answer is yes, we are going to give the constant rate. So what is the rate? So we're going to divide 24 divided by 1, and that will be 24. 45 divided by 2 is 22.5. So we already know it's not proportional. 78 divided by 3 is 26. And 100 divided by 4, you don't even need a calculator, is 25. So this is not a proportional relationship. And that was number of students according to number of buses. So what this means here is that we've got one bus with 24 students, one bus with 2 buses that have 22, it evens out to 22 and a half students. Of course, you can't have a half student. When they filled 3 buses with 78 students, the proportional rate was 26 students per bus. And with 4 buses, 100 students, the proportional rate was 25 students per bus. So because these are different, this is not a proportional relationship. But let's look at money earned for hours work. So 36 divided by 4 gives us $9 per hour. 72 divided by 8 gives us $9 per hour. 90 divided by 10, $9 per hour, and 135 divided by 15 is also $9 per hour. So yes, this is a proportional relationship, and the relationship is $9 per hour. So I don't know if they're babysitting or working at McDonald's or Home Depot, but that's the amount of money they make. So now we've got movie tickets sold and revenue earned by the movie theater. So 175 divided by 25, then we're going to do 260 divided by 38. We'll do 300 divided by 42 and 440 divided by 64. And in 175 divided by 25 gives us a nice even 7. 260 divided by 38 is $6.84. 300 divided by 42 is $7.14. And 440 divided by 64 is $6.25. So that is not a proportional relationship. So if you'd like, it'd be a good time to pause the video and try number 4, 5, and 6 on your own. Okay, I hope you've tried those on your own. So we've got next gallons of gas used for the amount of miles driven, and that is something you're going to want to know when you start driving. So let's see if this relationship is proportional. So 21 divided by 1 is 21. 42 divided by 2 is also 21. 63 divided by 3 is 21. And 84 divided by 4 is also 21. So yes, we do have a proportional relationship. And the gas mileage on this car is 21 miles per gallon. Now we'll move on to the number of candy bars purchased and what they cost. So let's see. So if we bought 4 candy bars for or 5 candy bars for $4, that would be 4 divided by 5. For $8, we bought 10 candy bars. For $16, we bought 20. And for $28, we bought 35 candy bars. So let's see what that costs. So 4 divided by 5 is 0.8. 8 divided by 10 is 0.8. Put an extra 0 and it's 0.8, not 0.08, so it's 80 cents. 16 divided by 20 is 0.8, and 28 divided by 35 is 0.8. So yes, we do have a proportional relationship, and that relationship is 80 cents per bar, per candy bar. Okay, let's go on to number 6. Looks like we might be downloading songs, and we'll see how long it takes to download them. This must be when internet was a little slower. Maybe they're using our Chromebooks at school. So we're going to divide 12 by 3, 15 by 4, 21 by 5, and 24 by 6. So we've downloaded 3 songs in 12 minutes. So when we make those calculations, that would be 4 minutes for that per song. 15 divided by 4 would be 3.75 minutes per song. 21 divided by 5 is 4.2 minutes per song. So it's not necessarily getting quicker. I guess it depends how long the songs are. And 24 divided by 6 is 4 minutes per song. And we can easily see that there is no proportional relationship there. So now what we have is we have some tables that are incomplete, and we will complete them. And we are told in our instructions, if the following tables represent a proportional relationship, complete the table. So Ben earns $8.50 per hour. That's proportional, bagging groceries at the grocery store. So now we're just going to take the number of hours and multiply it by 850. So this would be 4 times $8.50, 8 times $8.50, 10 times $8.50, and 14 times $8.50. And 4 times 850 is 34. 8 times 850 is 68. 10 times 850 is 85. And 14 times 850 is 119. And this is the proportional relationship. These all are because they told us they represent a proportional relationship. Now in number 8, we are told that the wide receiver can run 9 yards per second. That sounds pretty quick to me. So we're going to multiply each one of these times 9, 1 times 9, 3 times 9, 6 times 9, and 10 times 9. And we should not need a calculator for this. 1 times 9 is 9, 3 times 9 is 27, 6 times 9 is 54, and 10 times 9 is 90. Now we've got Mitch, who pays 30 cents per minute, so another proportional relationship, to make these long-distance phone calls. So we'll multiply each one of these times 0.30. And so when Mitch talks on the phone for 5 minutes, he spends $1.50. When Mitch talks on the phone for 12 minutes, he spends $3.60. When Mitch talks on the phone for 24 minutes, he pays $7.20. And when Mitch talks on the phone for a half hour, he pays $9. And then finally, our last problem of the day is about real estate. The real estate office sells 7 homes per month. Pretty steady practice. Complete the chart, then determine, so we have a little bonus problem here. How many homes will they sell in 2 years? Okay, so we're going to have to multiply by 24 months. 2 years is 24 months. So 7 homes per month, 2 times 7 is 14. So and that's 2 months. In 5 months, they will sell 35. In 8 months, they will sell 56 homes, and in 10 months, they will have sold 70 homes. Now, let's answer the second question. How many homes will they sell in 2 years? So let's see, 2 years is 24 months. And 24 times 7 equals 168. So in 2 years, they will sell 168 homes. And I hope they're beautiful homes, nice enough for you and I to live in and do some more math. So good job, guys. You've been working hard. I love how you're staying with it to the end of the year. Great job. And remember, as always, with practice, you'll be great.